All right, so what I'm going to do, you can see my screen there. This is our current course web page, but if you go under the Gamut Globe K menu, you can see this Sage Gauge 2021 course. That's our beginner's course. It was just a one-day course to get people started from the very beginning. And you can see down here, the last thing for session 2 was a few examples of how to get started with this kind of stuff. So we do have examples of this. We just don't include them in this course. It's included in the beginner's course, the one-day course, rather than the 5-day course. But if you want to go and play with these, that's absolutely fine. And what I'm going to do is I'm going to do a sort of combination of example 1 and example 4. So example 1 takes you through translating from raw files to Rhinex, because maybe some of you have done survey work or something like that, and you have raw files that you first need to turn into Rhinex. From there, example 1 takes you through building the 2 main files that we need to prepare for Gamut. One is the station.info file and the other is the .apr file. And then example 4 takes you through just a random, we pick a place in California and say, okay, we want to study this area. So how do we go about building our network and doing the processing? So I'm going to do a combination of those 2, but I'm going to do it with different data, because I want, to some extent, I want you to understand how the steps that are described are generic to any given data set. I don't want us to just be in a situation where you are copying me. I want us to be in a situation where we go through the sequence, but you can follow along with your own data, or you can see how this would be applicable to your own data set as well. So I'm going to do a hybrid of those 2 examples, but I'm going to do it with different data. So let's start with example 1 here. And you can see that there is a log file from a survey that we did several years ago in 2018, I guess. So this is a survey that was done. We went out to the field, we measured some sites, we took down the information of those sites, and then we came home and we want to process that site. We also have this raw file here, and we have a README. The README says, this is an example of preparing Rhinex data, station metadata, and approximate coordinates from raw files and field logs for input to Gamut. We provide a raw file from a Trimble receiver, and sorry, I just have to let someone in, and an accompanying log from the North San Francisco Bay 2018 survey. And there is a DOI here where you can go and cite the data from your nav code. The first step is we are going to take the information that we know about the site from the field, plus the raw file, and we're going to translate it into a Rhinex file. This information is necessary to put into the Rhinex header, which is why we have to read it from the log sheet and things like that first. The second step is to actually build the commands using the data that we've read from the log sheet and converting to Rhinex using commands. The third step is we're going to, again, read that metadata, what we call metadata, the receiver and antenna information, the height of the antenna, things like that. That's what we call metadata. We're going to read that into a station.info file. And finally, we're going to calculate an approximate position for the APR file. And this README here from the beginner's course takes you through this step. I am actually going to skip steps 1 and 2. because I've already made my Rhinex files for the data that I'm going to use. I've already been through those 2 steps. So I'm not going to do that. I'm going to just jump straight in and take the Rhinex files that I created for a network that I have. So let's see that network. So I'm going to be using this network of 3 sites in what's called the Geysers. It's in California, in Northern California. So this is what I'm calling my project. Hopefully you have a project of your own. Hopefully you have some, whatever it might be. Maybe you want to measure a rift that is expanding. Maybe you want to measure a volcano. Maybe you want to measure an earthquake. I don't know. This is my project. I would like each of you now to decide what project you want to do. If you don't have anything in mind, then you can probably just follow along with example 4 in the beginner's course. That just picks a random place in California to do. But either way, it's important to bear in mind what you would do for your data following what I'm demonstrating here. So let's talk a little bit about what this project is for me. This area here is a geothermal field. Steam comes out of the ground, it drives turbines, and the turbines generate electricity. As the steam is pulled out of the ground subsides. To regenerate the steam underground, the company that operates this area actually injects water back into the ground. So in that case, the ground might slow down subsiding, or it might actually come back up a little bit as well. So the idea behind these 3 sites being here is we want to measure how much is the ground subsiding and contracting versus uplifting and expanding. So that is the scientific problem that I want to address with this network. So because that's my scientific problem, I'm thinking ahead to the very end regarding how do I want to visualize my data? What's the most reasonable and appropriate reference frame to use to see this potential subsidence and contraction or uplift and expansion? And the most meaningful reference frame would probably be to look at these sites relative to the area immediately outside the geothermal field. So in this case, it's a little bit like a volcano problem, where we have something in the middle that we want to measure. And so our reference frame will be essentially fixing everything around the outside to 0. And then we can see the relative motion of what's happening in the middle. So that's ultimately what we're going to do at the very end. Again, for your data, for your project, you might have a slightly different geophysical problem. Therefore, you might have a different way that you ultimately want to realize your reference frame. So bear that in mind. I'm thinking ahead to the very end as I start building my project at the beginning. So I have these 3 sites. What I'm going to do now is I'm just going to grab a few Rhinex files for those sites, and we're going to start building our station.info file and our APR file. So let me just grab some of those files. Switch to my terminal here now. I'm going to create a directory where I'm going to do all of my processing. So I'm just in a temporary directory here to do the demonstration. And this area is called the Geysers. So I'm just going to call it the Geysers continuous GPS demonstration, something like that. And I'll change directory there. and create a Rhinex directory where I'm going to copy some of my data. So now I need to remember where my data is. It's on a machine at MIT. So it's in North San Francisco Bay. Okay, there we go. All right, and you can see there I have all of my Rhinex files since 2012 through to 2022. They're all prepared and ready for the 3 sites, TG01. We have some from TG02. And we have some from TG03. So there's 3 sites in this network that I'm going to be processing: TG01, TG02, and TG03. So I'm just going to copy some of these files. I'll copy, let's see, do we have files for the first day of the year? Nope. Let's see, what do we have? Oh, oops. Media directory. Okay, great. So we have 3 files, one for each site on the first day of 2022. So I'm just going to process 1 day for now. We'll get everything set up. We only have to do the setup once, and then I'll process 1 day. And once we've done the setup, we can process 1 day, or we can process all of the days. It doesn't matter. The setup really is just something that you need to do once. So I'll copy those files over to my local machine. They will go in the Rhinex directory. I did it again. To include the year. All right. Okay, great. So now we have a Rhinex directory with some Rhinex files that are part of my network, part of my project, and those just go in there for us to do the setup with. I'm going to process the year 2022. So what I'm going to do now is actually just run sh setup for the year 2022. And now I have a tables directory. So now I'm going to, this is where the examples become a little bit of a hybrid. I'm going to go back to the example here. So we are going to do steps 3 and 4. And we're also going to go through the same steps here as part of this. So I'm transitioning from one example to the other here. This example is, again, we just pick a random area in California. I am working off to the north area. You'll be working, somewhere else perhaps. But either way, what we're doing is we're preparing our metadata files. We're preparing our station.info file here next. So the first thing I'm going to do is create my own station.info file. I'm just going to take this header line here and create a station.info file just with my sites in it. I'll just call it TG for the geysers. All right. And in order to do that,
are you sharing your screen?
oh, sorry.
Because we are not seeing, we are just seeing a PowerPoint or something like that.
Yeah, thanks. Okay, you can see it now. Yeah, I'm going to be switching screens a lot. So if I do, forget to change my sharing, just let me know.
Okay, thanks.
So yeah, all I did was I just went to the main station.info file and I just grabbed this line that begins with site. That's the main key word header line that you need to have in your station.info file. I added it to a file that I'm calling station.info.tg. I just want to get the information from my sites first, and then we'll continue with building a network around my sites. So here I have a site called TG01. It operates from 2012 sometime, I can't quite remember. But if we look in the Rhinex header file, we can see the Rhinex header information here, the receiver and the antenna information. So that's what I need to put in here. The site is called TG01. Say I can't quite remember exactly what start date it was, but let's just say the 1st of January 2012 at midnight 000, and we can leave this 999 just means an endless date. The antenna height is listed here in the Rhinex file, in the Rhinex header. This is all assuming that the Rhinex header is correct. I know that these Rhinex headers are correct because I made the stations and I kept notes and I made the Rhinex files. For other people, you may need to contact the station operator in order to verify this information. We are using a Trimble Net R9 receiver with firmware version 4.62. And the receiver number is that. And then the antenna is that. There is no radome, and the antenna serial number is that. Okay, so there we go. There is one entry for TG01. And I do the same thing for TG02 and TG03. I can do it manually from the Rhinex header by copying and pasting. I could also just use the Rhinex files directly using a script called sh update stinfo. And you've seen this script before in the test install. And so what I'll do is I will just unzip my these are Hatanica compressed and then gzipped Rhinex files. We need to have the original raw data. So I'm going to use this program CRZ to RNX. It's built into Gamut. You can use the script sh crx to RNX to do this. And now I have a series of O files, which is what we really need. So here's the help page for sh update station info. And what we're going to use is we have a reference station.info. That will be my file because I want to add TG02 and TG03 to the file that I just created. And we are going to use this option, -files R files, where R files are Rhinex files to be used to update station.info. So I am adding information from the Rhinex headers using this script rather than copying and pasting myself like I did for the first site. So I'm demonstrating two different ways of doing the same thing. So my reference is the file that I created before. I want to include TG01 and TG02, and I want to output to the same file name. So I'm going to write to the same file I started with. So we'll append to that file rather than generating a new one. Okay, so it does that quickly. And now let's look at stationinfo.tg. And now we see there's that first line that I put in myself manually. And then we have two more lines from these files that complete the station.info file for the second and the third site. Now, notice here that the Rhinex file starts at the beginning of the first day of 2022 and ends at the end of that day. So our start day and end time are just one day. If I want to process more than one day, I need to have an entry that encompasses that entire time. If your equipment has not changed over time, then we can just edit the start and end time. So again, I'm just going to make this the beginning of 2012, and I'm going to have it go forever because my equipment hasn't changed. If your equipment has changed, then you can just have one line for one set of equipment with the start and the end time for that equipment. And then you add additional lines for each change of equipment, again with an appropriate start and end time for that particular set of equipment. So I'll just pause here for a moment and ask if anyone has any questions. Are you following me?
Yes,
yeah.
I have one question, Mike. I saw that in the receiver .dat file, you have the ublocks set F9P receiver. As I said yesterday, I use low-cost equipments, and also I have one calibrated antenna. Not from Trimble is also a low-cost antenna from Ardu Simple, but it's calibrated there in the NOAA NGA's office. No, and I ask you. Is the information about the receiver name, brand, and firmware, and the antenna description is really necessary to be configured, or I can put it in the file of the antenna data that you have in the tables directory, or how do I solve that issue? No.
Yeah, that's a good question. So the convention for station.info is that the receiver type here and the antenna type and the radome type as well here, they are what's called IGS codes. So every receiver and every antenna has a unique IGS code that is generally something like this. It's all capital letters and numbers and things like that. Those IGS codes you will need to know for your equipment. Gamut will not automatic, if you just say, oh, I have a U-Blocks receiver, Gamut doesn't necessarily know which one. It doesn't really know what the IGS code is. So you do have to understand what the IGS code is.
Okay.
And as you said, we actually have a table in GG tables. It's called rcvant.dat.
Yeah.
This lists all of the IGS codes that we know of, plus some receivers that do not have an IGS code, but we have given them a code just so that we can process them in Gamut.
Okay.
So for example, let's go and find the Trimble receivers.
SkyTrack or something like that, like those receivers that are really not popular. Well, not
U-blocks, I think.
low cost, really. No,
Yeah.
SkyTrack.
Yeah. So anything this is basically a copy of an IGS file, and it's just changed slightly to be used for Gamut. But anything that just says, Trimble receivers or whatever, these are all IGS codes from the IGS. So, down here we have we were using the Trimble Met RS, and you can also see that there are some Trimble receivers added by MIT.
I know.
So these are receivers that do not have an official IGS code, but for Gamut, we have assigned a code for them so that you can still use them. So there's the Trimble BD750, BD970, and you can see right below that is actually the
U-blocks.
U-block receivers. Yeah. So we added that line. I don't know if the U-blocks receivers have an official IGS code. They might do in the future, but because I wanted to process U-blocks receivers, I just added a line to this file, and the information that goes in the station.info is this second column here.
Okay.
So it would be U-blocks space F9P. That is the information that goes in the receiver type in station.info.
Yeah. Not the first column, the second one.
Yes, the second one. Yeah. Okay. The first column is a Gamut internal code.
Okay.
The second column is the sort of IGS code. Okay. Yeah, and that's what goes in station.info.
Thank you.
So what antenna are you using?
I am using the Ardu Simple antenna. I can put in the chat the URL. Ardu Simple.
Okay, this one.
Yeah, let me see if I can find it.
Yeah, do you have a like a part number or something like that? These numbers here, like ANT2B cal, ANT3B cal, they're usually the part numbers.
Yeah. And I use that name to find it in the RTK Live library of antennas, and because they registered the antenna with the NOAA NGAs, because they calibrate the antenna for them, not for Ardu Simple. But I am going to put it in the chat because if you want to see it later.
Yeah. Now this is really a really good question. It sort of it demonstrates to everyone that what I'm doing right now with building the station.info file does actually have some potentially complicated things with it. If, like you have some non-standard receiver that you're trying to process with. So this is really helpful. Yeah.
Well, thank you.
Okay, so and we keep this file updated.
I have one question. For the station info in the version part, if, for instance, in our Linux file, the version is 2.11 /2.12, is it okay to write it this way in the station info file?
So there's two columns in the station.info file. The first one is version.
Right.
And the second one is software version. Software means the Gamut equivalent. This column can be anything, whatever the receiver reports.
Okay.
This column is a numerical value, a 2 decimal place numerical value that is specific to gamete. And so I don't want to get too sidetracked by this, because this is probably going to confuse other people who don't have this kind of problem. But I'll answer the question very quickly again, like I did with Jose's question, and then we'll try and move on a little bit with this. So we have another file in, where is it? In gamete makex called set time. And this is a part of the Fortran code. And you'll see here that we have many different versions of, let's say, 4 Leica receivers here. There's a set of comments that says, you know, for a Leica Series 500 dual frequency receiver, we use the value 5.50. A lot of the time, the firmware that's reported by the receiver, we just use the first numerical value of that. Sometimes there's some additional ones, like, let's say, here, this one. The Leica GR25 has 120 channels, firmware 3.30, but for that, we actually use 9.03 for the software version. So in general, this doesn't actually matter anymore with modern receivers. This was a problem many, many years ago when a lot of the receivers had problems keeping track of time. So this value allowed gamete to understand, you know, how good is this receiver with its clock? Do I need to add a little bit of variability, or is it pretty accurate? Almost all receivers now are pretty accurate. So these numbers don't actually matter so much anymore. You could just write it as probably 0 and it would be fine. Oop. So you could probably just write it as 0 and it would be okay.
Right.
It's not going to make a very big difference to what the processing is going to do. Yeah.
Yeah, and here for versions, as you also see in the file that you opened, for instance, if it's 4.61/4.51, is it okay to write it this way also for versions? Because for instance, in one of my files, the version of the file in the Linux, it's, let me read it for you, is 2.12/2.121.
Right.
So is it okay to write the whole numbers with the slash even?
It's okay to write that in this column, but not in this column. Oh, not in this column.
In this, okay.
So usually, the reason this is a 2-digit number is for most receivers, the first part of their firmware, reported firmware, is a 2-digit number.
Right.
So if you have something like 2.12/something, something, something, the number that goes in the second column here is probably 2.12. But you can check that with this file, gamete makex settim. So what kind of receiver are you talking about here?
The receiver, let me tell you. Okay, the GNSS receiver is Leica GRX1200 Pro.
Okay, right. So here we have this, GRX 1200 GG Pro, or sorry.
Yeah, yes.
Yeah, okay. And here we have actually an example.
Yeah, exactly.
2.12 or whatever, yeah. So in this case, it seems as if we are assigning numbers that are 7 point something something. So you could use 7.30. something like that.
Okay.
So you can just have a look at this file, find your receiver, and see if anything has been assigned for it.
Yes. And what was the name of this file that you opened? Because I couldn't see what you type in terminal.
Can you see the bottom line there?
Now I can see a station.info.tg, the last one. Let me open
Okay.
it.
I can see my full screen. So is anyone else not seeing the last two lines?
No, we can see that. We can see.
We can see it. I can see them.
Okay, so because for me it's Wim station.info.tg.
Yeah, that's the third last line on everyone else's screen. So I wonder if
the problem is maybe that the status bar of Zoom
you need to
is hiding you that area. You have to move the mouse or outside the button of the
I find if you hit
of your screen.
Alt,
Okay, I saw it in the
it'll toggle out.
Okay, good.
Okay. All right, so I'd like to move on a little bit before we get into questions, because there are some people who just want to see the sequence, and I don't want to have people get too confused with these tangents and start to worry if that's something that they need to consider. You know, this is where these kind of courses get a little tricky, because a lot of people do have more detailed questions. Other people just want to see a very simple example that works, and then they'll come on to the details later. So let's move on a little bit with this. The next thing I'm going to do, I'm moving on to, it's my Firefox. There we go. Okay, so now we are going to do number 4 from example 1 of the beginner's course. We are going to create a priori coordinates from our for our sites, for those three sites that I have in the geysers. Share. And again, I'm going to show you 2 ways of doing this. In fact, I'm going to show you more ways of doing this. So again, I'm just going to create a file. I'll call it tg.apr. This is just going to be for my sites. And I need lines for each of my 3 sites. So the first thing I could do is I could just look at the Rhinex file. Here we have an approximate position. This is in geocentric XYZ. So I could just paste that in there and do the same for TG02. And do the same for TG03. Okay, great. Now the format of this file, if we look at the main file, you can see the format here. So I'll just copy that into this. So we need the X, Y, and Z geocentric positions in meters. We also need a velocity in X, a velocity in Y, and a velocity in Z. And then we need an epoch. So at the moment, we don't know the velocity of these sites. So we can just say 0 in velocity in X, 0 velocity in Y, and 0 velocity in Z. And because we have 0 velocity, the epoch doesn't really matter as well. So let's just say 2012, when the sites started. Okay, so that's one way of creating the a priori file, just pulling the coordinates, copying and pasting the coordinates from the Rhinex header, like we did with the station.info file. We just copied and pasted information from the Rhinex header. But remember, we are assuming that that information is correct. That is not always a good assumption to make, but here we are assuming that the information is correct. So a second way of doing this is to go and use the Rhinex files directly to estimate a very quick, what's called pseudo-range solution. For this, we actually need to download some navigation file data. That will be downloaded by shgammet, but in order to get an a priori coordinate, we're actually going to do it manually now so that we have the files available to use for a quick data solution. So they go in this directory brdc. So I just created that directory here. And we will go in there and we will use the script shgetNav to get the navigation file for the day that we are going to be processing, the first day of 2022. So that's the command shgetNav -yr 2022 -doy1 for the first day of 2022. Okay, and now we have this brdc 0010.2022n. That's the file that we're going to use for this quick pseudo-range solution. So I'll go back to where my Rhinex files are. And now I run the command shrx to APR. Again, this is all in that README file from example 1. Okay, I'm not doing anything different to what is already described in example 1 of the beginner's course. So let's see what that needs. We need a site, a full Rhinex file, and we need a navigation file. Navigation file there. So I'll do tg01 first, and my navigation file is up1 directory into the brdc directory, and the file is in there. Okay, and that creates a tg01.apr file. I can now copy that into the file that I was creating in the tables directory. I do the same for tg02 and tg03. I will just cat those into the tg.apr file in the tables directory. So now, can we see any differences here? There's two methods of getting your a priori coordinate. Remember, the a priori coordinate ideally should be within maybe a meter for gamut at least. So what kind of differences are we seeing here? We have about 3 meters difference in in X for tg01. We have about 10 meters different in Y for tg01. And we have about 7 meters difference. So you can see that the Rhinex header is probably a few meters away from an actual sort of data solution. But we can do even better than that by including a reference site in our SHRX2 APR run. So that way we get a differential solution. If we have a reference site and we know its coordinate very accurately, we can determine the position of our site relative to that known coordinate a little bit more precisely. And for that, I'm going to do a little bit of research. So, is everyone still following me?
Yeah, closely.
Yeah.
Good, good. All right, so we know, whoops, sorry, I need to share something different. I'll go back to my Google Earth. Okay, just to remind you where we are in Northern California, just north of San Francisco here. This is San Francisco Bay, and this is a lake called Clear Lake in Northern California. So that's where we are. So I want, for my reference site here for this quick solution for an a priori coordinate, I want to choose an IGS site that we know very well, but is quite close by. So let's go and have a look for a site that fulfills those criteria. And I will go to igs.org/network in order to do this. All right, so let's zoom in to our sort of Northern California area. So it looks like we have two sites that could be fairly close by. This one is called Quinn, and this one is called STFU. So we could use either of those as our reference site here. So first, what I'm going to do is I'm going to check if either of those sites is in the main igb14com.apr file, because that's what we're going to use for this. Okay, great. So Quinn is in there. That already has an accurate, well-known coordinate, so we could use that one as a reference site here. And STFU has a coordinate in there as well, so we could use either one of these. So I don't know, just for fun, let's use both, and we'll see what the differences are again. So I'm going to download those files. Again, for the year 2022, day number 1, I want Quinn, and I want STFU, and the program I'm about to use, SHRX2APR, unfortunately still only uses RHINEX2. So we have to make sure that we download RHINEX2 files. So we add that -RX2 option. Let's see what we get. Okay, there was nothing at SOPAC. So let's try CDDIS. We're going to try the CDDIS archive, which should have these IGS sites. All right, it looks like we have Quinn, but it doesn't look like we have STFU. So STFU apparently does not have data for this day. That's okay. We still have this Quinn site to use. So let's look again at what we need for this SHRX2 APR. We need the site name. So I'm going to do TG01. We need the navigation file name. So again, I'm going to use the same thing. We need the reference site. And we need an APR file that contains the coordinate for that reference site, which is the main combination file. All right. And I will do the same thing for TG02 and the same thing for TG03. Now I have 3 files, TG01, TG02, and TG03.apr that contain the coordinate estimates using Quinn as a reference site with a known coordinate. So I will again just add those to my APR file. And let's see what difference that makes. So now you can see that there is again a little bit of a difference in these coordinates. In fact, if anything, the reference site, using the reference site, is closer to the Rhinex header than the other one. So this suggests that maybe there was some bad data on this day for TG01. Either way, I would recommend using this method to get the most accurate a priori coordinate. So I am going to just comment out these lines here so that we only use these lines. Okay. Great, done. So now we have dealt with our sites in the station.info file and in the APR file. We have now reached the end of this README file. So you can see here, it's just the steps that I took, almost exactly the same steps. In fact, we use the site Quinn for this as well, because the data that I provide in this example is also from Northern California. We downloaded a navigation file. You saw me do that with shgetNav. And we ran SHRX2APR with the site that we want to get the a priori coordinate for, a navigation file, a reference site, and an APR file with a coordinate for the reference site. There we go. So that's basically steps 3 and 4 in this README file. And that is equivalent to slides 8 and 9 in example 4. So it's just, this is where I say I sort of did a hybrid. There's a bit of a crossover between example 1 and example 4. So let's pause there. And if there's any questions, or perhaps you can tell me if you have selected an area that you want to work with, and have you been able to follow me through with these steps? Would you like some time to try to do this yourself before we move on? This is a natural pause point. Now that we have generated our station.info file and our APR file for our sites only, this is a sort of natural pause point. So any questions? Did we have some in the chat maybe? Okay, yeah, Joshua said falling behind a little bit, that's okay. Sometimes if you have more sites, it takes a little bit more time to get the tables together. I think the big question is, do you understand what you're trying to do? And if the answer is yes, then just take a little more time to finish that table. Yeah.
Yeah, I have a question, Mike.
Mm-hmm.
Yeah, it doesn't make any difference to use the precise SP3 file instead of the broadcasted navigation data, it doesn't make any difference, no? Because will be only centimeters difference, no?
Exactly. Yeah. For this quick solution, we're actually just using the pseudo range data, not the phase data, which is what Gamut will use later. So there's a certain amount of imprecision. There's not a great precision there anyway. So the navigation file is good enough. And as you say, it's really just a meter maybe difference here between the methods, that's good enough to get started with Gamut. Yeah.
Okay, I have another question, Mike. Excuse me. I have all my data that I'm collecting in Santo Domingo City. Is the capital of the Dominican Republic. I am collecting in different places. I have chosen 4 or 5 sites, and I used to occupy those places maximum 6 hours because of security reasons or things like that. No? And yesterday I told about this arrangement layout that I am doing here, no? And Tom told me that there is a parameter that needs to be configured in Gamut to accept observations that are so a few hours, no? Maybe I have 4 or 6 hours of data collection. What is that parameter? Where can I find it?
I'm not sure what Tom's answer was speaking about there. If you have if you only want to process 4 hours or 6 hours, then the option is in SH Gamut, or in fact in process.defaults. I'll show you both. If you go to the SH Gamut help page, you'll see this option here, the session info. The 3 arguments are the sampling interval. So most of the time we have 30-second data. So that would be 30. The number of epochs, so in this case, 24 hours of 30-second data is 2,880 measurements.
Yep.
And the start time, 00 is midnight. If you only wanted to process 4 hours of data, you would change the 2880 to however many epochs there are in 4 hours. So 30 seconds, that's 120 per hour. So 4 hours would be 480.
It would make any difference to use 15 seconds, no, of interval, no?
You could do, but it probably won't make very much difference because, well, there's 2 things to say about that. Number one, because Gamut is a double differencing software, if you use 15-second data, all of the sites that you are processing together have to have 15-second data.
Yeah, I have them.
Otherwise, a lot of that data gets thrown out because you can't form a double difference at 15 seconds and 45 seconds past each minute. The other thing is that there is a certain amount of correlation between these measurements, and we have some parameters in Gamut that take into account short-term correlations. So if you were to process with 15-second data versus 30-second data, because of those temporal correlations, the result will probably be very similar. It probably won't help very much. So 30 seconds is standard. Yeah,
it's a standard. Okay, thank you.
Yeah, but I will say you don't have, if you have a site that you measured for 4 hours, you don't have to process everything for only 4 hours. You could have 4 hours of data within a full 24-hour window, and you could just process the full 24 hours as you would normally do. So all of the other sites in your network have a full day of data, but your site just has 4 hours in the middle. And that's okay too. You don't have to process only 4 hours because your site was only measured for 4 hours. You can have a full day of data and your data will come in for that 4 hours.
I don't understand that part precisely. Well, because I have only 4 hours of data, no?
Right, but the other sites that you have around, like your IGF reference sites, they have 24 hours of data.
Yeah.
So why not use all 24 hours of data for the reference sites? So yeah, just because you measured for 4 hours only doesn't mean that you have to process for 4 hours only. Yeah.
Okay, I understand now. Okay, thank you.
Okay, so any other questions, or shall we move on with the process?
I do have one question. So with the project that I've been working on, we've been gathering data for probably over a year now, I would say. And we've been kind of keeping track of it with, I guess, some more basic softwares just to kind of get an idea on where things are. And so we kind of have a, I guess, running average position of each one of our stations with over a year's worth of data with like centimeter precision, I would say. And do you think that would be a good starting point for creating the APR file?
Oh yeah, definitely. Yeah, if you have precise results from anywhere else, yeah, that should definitely go straight in the APR file, and you don't need to worry about any of the stuff that I just did. If you have an independent estimate of the position, an accurate independent estimate of the position, that's perfect to start with. Yeah, absolutely. Just copy those numbers in the correct format.
Got it. Thank you.
Yeah, just make sure it's those geocentric XYZ, the format that's expected by Gamut.
Yeah. For example, the NRCan PPP results, for example, or Auspos.
Yeah. Any of those online services will give you something that's probably good to 5 centimeters or so. So yeah, you could use that definitely.
Okay.
Yeah. Whether it's any quicker than just doing SHRX to APR, I don't know. I mean, it takes time to do the opus and everything as well. Either way, we just need something that is within a meter or so accuracy. Yeah. Okay, we have about 15 minutes of this session left, so I'm going to move on a little bit, and we are going to start focusing on the rest of example 4. So I've already defined, slide 1 here defines the geophysical problem that I want to solve. I did that for you. I talked about the geothermal area, the fact that we have 3 sites in the middle of the geothermal area, and we want to see how they move relative to the immediate surroundings of that area. Very similar to, to this example 4 here. So the question that I would like all of you to consider over lunch and over the next few days is, what is your geophysical analysis? What is your goal for the data that you are using? That will be a good way to start this process of setting up your experiment. So in example 4, we have this area of subsidence in Southern California. In my experiment, I showed you those sites in Northern California. But either way, what we're doing is, the next thing we're going to do is we're going to look at our region of interest, and we're going to start to pick some sites that we can use to process with our sites. We can process more. We're going to pick some sites to include in our processing network so that we can define, the surrounding area when it comes to the reference frame, and we'll include some IGS sites in there as well. So in this instance, I went to this web address here, unavco.org.data/doi. So let's go there and look at my area, and you can hopefully follow along. So let's zoom in on the geysers area. Okay, you can see here, Clear Lake, and you can see here, San Francisco, and the geysers is in this area near the town of Cobb. So we have P203, P206, P204 are in the immediate surrounding area. We could have P195, we could have P269 up here, P208, and so on and so on. And where I'm going with this is we make a note of those local sites because we are building our sites.defaults file. So I'm going to start doing that now. We already have.
You need to share your screen again.
Yeah, thank you. We already have our tables directory. And in there, I just want to make sure that we're all following that this is, quite simple. In there, we created our station.info.tg file. We created our tg.apr file. And now we are going to create our sites.defaults file. You already have a template here of some things to use. So I'm going to call my experiment the geysers continuous GPS, 4 characters. So you choose your experiment name. Doesn't matter what it is, as long as it's 4 characters long. And so I will start making a note of some of those sites that we just saw. So we had P203, P204, P206, P195, P188, P269. And these are NOTA sites available from UNAVCO. All right, so there's a few. Next, I want some IGS sites. So I am going to continue with, so we were looking at the UNAVCO archive. I'm going to move on to the next slide, and I'm going to start looking at that IGS network and see what sites we have in the area from the IGS. So we can just zoom in. So we have we have Quinn. We have STFU, we have this one up here, which is P389. We have VNDP, COSO. So I'm just going to add these to the list. You don't need to see this necessarily. So what was it? It was Quinn, STFU, what was it? P389, something like that. P389, yep. VNDP, yeah, okay. Okay, so you can see that I just added each of those sites to this list. So I'm building up a network around my sites that are going to be used ultimately to define the reference frame. And you can go quite far. you can go into, from Northern California, you could go to the East Coast of the United States, you could go up into Canada, you could go across to Hawaii, you could go down into Central America and the northern part of South America, or even further. I'm going to leave my list at that right now because we're running out of time here. But I just want to recap that we've done 3 things. We've set up 3 files. Number 1, we have added the information from our sites to station.info. We have generated a priori coordinates for our sites, and we have added them to an APR file. And now I am building up my processing network with sites in addition to my sites. IGS sites around the place, ones that are available from your Navco. You could grab ones that are available from any public archive, but unfortunately, you need to go and do this. You need to go online, see where your project is, look for sites in the surrounding area, and include those explicitly. So I also need to make sure that I have my experiment name the same throughout. This is the experiment name that I'm going to use. And finally, you will note that for each of these sites that I want to download, I have the FTP RNX flag listed. So this tells SHGammet, please go and get this data for me for this site. And it will try UNAVCO, it will try CDDIS, it will try SOPAC. But that's the basic setup. We've created a station.info, we've created an APR file, we've created a sites.defaults file. Everything else will follow from there as we start our processing. So we're out of time here. So I'm going to stop this part of it.
Mike, I have a suggestion. Maybe since at that point, the software is going to take a lot of time downloading. Maybe you can put it to download now, and then when we come back again, I don't know if we're going to continue with this, no? But maybe it can be downloading because that process take a lot of time, no?
Downloading will just take a few seconds.
Yeah.
Okay.
Okay.
Yeah, we still have a little bit of preparation work to do. So far we have only defined our sites. The next thing we need to do is combine that our station.info and our APR file. We need to combine that with the information for the other sites. So that's what we'll do when we come back to this next time. So I'm not going to start it right now, but we'll come back to that. We have the merging to do next.
Okay, thank you.
All right, so I'll stop my share there, and we just have a couple of minutes to lunch here. So are there any other questions? As I say, I think at this point, I know I have every confidence that you can copy what I'm doing and follow me along on screen. The big question that I think needs to be answered is, are you confident enough to do what I just did with your own data set, with your own project? So over lunch, I would like everyone to think about what they want to do. We asked you at the beginning of the week as well, but just rethink, what is it that you want to do? And do you feel comfortable taking whatever data you have to use and doing those steps that I did, making the station.info file and making the APR file? That would be an excellent thing for everyone to do by the end of today, by sort of following that sequence that I did. So have a little bit of a think over lunch. And when we come to the interactive session after the next lecture, then we can continue with this setup. Okay, any questions? Okay, great. I'm going to stop recording then.